Hello, everyone. Hello. I can see that Olivier is joining from Brussels. Marlene is joining from Germany. John's joining from London. Hi, John. Susan's joining from Chicago. Ooh, Ayodeyi is joining from Nigeria. I hope I pronounced that right. Elaine is joining from somewhere. And Pallavi is joining from Brooklyn. Hi, everyone. Welcome, welcome. Hi, Nicole from Sweden. Hi, I'm Matthew Shripman, and I'm an environmentalist, a scientist, and the head teacher at AimHi Earth. So AimHi exists to activate millions of nature-first thinkers and to transform global understanding of the climate crisis. We are working to ensure that people everywhere understand the truth and are able to drive positive change so that we can build a healthier, cooler, more verdant future together. Hi, Sarah from Yorkshire. Carol is joining from Ohio. Hello. So this course is called Climate, Nature, and How to Make a Difference, Everything You Need to Know. Now, whether you are here to learn about the details of the crisis, our best solutions, how to lead, how to take action, or how to teach and communicate effectively, or all of these things, we hope that you enjoy the course today. This course is generously supported and made possible by Cambridge Zero, so the University of Cambridge, the Eden Project, the UN Environment Programme, and an even longer list of wonderful friends whom we'd be nowhere without. If you like what you experience here, then please recommend AimHi Earth to others. With this topic in particular, there is no time to lose. Session 1 is actually running again this Sunday, so it's not too late for other humans to begin the course. We will also be running this whole course again sometime soon. Please help us to change the course of history by inviting as many people as you can if you like it. Also, if you're one of the couple of people who signed up for this course from a climate communication organization, please do get in touch with us if you'd like to collaborate afterwards. So yeah, please take notes and ask questions as we go. Feel free to comment and interact using the chat whenever you'd like. There is no such thing as a stupid question here, and please never feel that your question will be distracting. We are used to selecting questions from a torrent as we go when we have hundreds or thousands of people on AimHi Earth sessions. And please also feel free to respond to one another's comments as we go along if you'd like to. And if you have any technical questions, then please write to one of the other AimHi Earth people on this call, as I won't be able to answer them during the flow, much as I'd love to be able to. We will also ask you a lot of questions, and we encourage you to guess something intuitive if you don't know the answer. Do not worry about being wrong. This is not about knowing all the answers. It's the journey that we're all going on together. So please check that your chat is working by typing your favorite crunchiness of peanut butter into the chat thread now. This is perhaps the only question that is a solid correct or incorrect one. And yeah, I can see that Marcy is spot on, and so is Natalie with smooth. Correct, right. So this session will run for about 55 minutes from here, maybe slightly shorter or slightly longer. And then there will be some bonus time at the end for extra questions, including any that we didn't answer before. Love to see all those smooths pouring in. So this course is not designed to teach you everything about climate and nature. It's designed to cut through the misinformation and fake news, and to equip you with the key knowledge, ideas, and confidence, because we want you to be able to weave stories and understanding about climate and nature into your plans and conversations, from chatting to friends through to what you do at work and decisions you make in life, great and small. Non-Newtonian smooth there from Alex. That is a very special kind of peanut butter. Anyway, so most people in the world don't know most of what's in this course. And this is knowledge that most people don't have yet. And that's why it's so important that you are all here to both learn it and how to communicate it. So thank you so much for being here. The situation is obviously very bad, and we're not going to sugarcoat that at all. But the purpose of these sessions is not to focus on how bad everything is. The purpose is to explain clearly why things are going wrong, what needs to change, what roles we can play, how simple and near many of the solutions are, and to help you to be confident communicators, teachers, leaders, and so on yourselves. If all goes well, then this course will leave you feeling empowered, understanding, keen to share knowledge, and ready to be a catalyst for change. So this first part is called Carbon Tipping Points and Our Simplest Solutions. So here we go. So today we're going to talk about the following things. We're going to start off talking about human psychology and perception. We're going to talk about tipping points. We're going to talk about global heating, CO2 levels, our simplest solutions, and then most importantly, what we can do. Now, if you're here to learn about how to communicate and teach effectively and with impact, then please know that this course is less designed to tell you how to communicate, although there are some bits like that, and more to show you how. Also, know this: facts alone rarely change the minds of many people, especially if we don't appreciate the full picture. We are creatures of stories. Some things stick in our minds and really shape us. So who knows what's going on here? Who knows what's going on in this picture here? What is going on in this one? What do you reckon is going on in this picture? So Rakeel is saying maybe it's some kind of kiss. So sometimes it can be hard for male butterflies in the rainforest to find salt. So if they're running really low, then sometimes they'll stop off to drink the salty tears of a friendly turtle. The females actually get all the sodium they need from mating with the males. But anyway, this isn't really where the session begins, but it is kind of beautiful, isn't it? This is where it really starts. So thank you for coming. So here's a piece of paper. Now, how many times do you think you can fold a piece of paper in half before it's impossible to keep going? How many times can you fold a piece of paper in half before it's impossible to keep going? What do you reckon? Okay, so Ollie's thinking 7, and this has gone for a very large 11. Okay, so yes, 7 tends to be the main number that people throw here, but I always get stuck at 6, mainly because I've been stuck on lockdown and I've stopped climbing, and so my fingers have become all weedy. There you go, I think I'm going to get 6 there. Anyway, the world record is 12 times with a really big piece of very, very thin paper. But anyway, with a normal sheet of paper, there's a limit because every time you fold it, the thickness doubles, right? And eventually it becomes too thick to bend. Now, I know that we can't keep folding this piece of paper in half, but if we could keep folding it in half and doubling its thickness, then how many folds would it take until it was as thick as the Earth, roughly? Just give me a guess if you don't have a clear idea. It's hard to have a clear idea of what that could be. Okay, so Mark thinks 32, Holly thinks 58. Okay, so Bella's gone for 68. It would be as thick as the Earth in just 37 folds. So the Milky Way galaxy is so big that it would take over 100,000 years for a text message, so traveling at the speed of light, to go from one side to the other. Now, this is actually Andromeda, because it's a bit tricky to photograph the Milky Way these days. Anyway, how many folds do you think it'd take before this piece of paper was as thick as the Milky Way? How many folds do you reckon it'd take before this piece of paper was as thick as the Milky Way? So Marlene's gone for 45. The low guesses are coming in now. Francesca's gone for 578. It would be about 83 folds. It would only take about 103 folds before this piece of paper was as thick as the observable universe. Now, why is this important when thinking and talking about the climate crisis? Well, it's because we humans aren't wired to intuitively understand how quickly things can grow when they speed themselves up. And it's nothing to be ashamed of or embarrassed about if you guessed numbers that were wildly wrong before, because it's how we humans all naturally think. On top of this, we've only really evolved to act quickly when we're faced with immediate threats, like a hungry tiger running at us to snatch the sandwich we're holding or otherwise. We never evolved to be instinctively scared of problems that investigations tell us are going to be dangerous if they don't feel dangerous right now. So does the climate crisis feel scary to you right now? And by that, I mean, is your adrenaline pumping now? So Joanna's adrenaline is pumping, but Alex's is not, and neither is Jenna's. Okay, so mine isn't. My adrenaline is not pumping. And understanding this is really important if we're to overcome some of the biggest challenges we face and help to communicate and act in ways that inspire and bring people along with us rather than alienating. For example, one of the most positive things that any of us can do is to remind and empower people and organizations who could take positive actions, but are delaying doing so, that there really is no time to lose, to patiently and kindly paint a picture of urgency. Now, we will talk more about this as these sessions go on, but to say it upfront and clearly, we all have a crucial role to play, no matter how small we might sometimes feel our contributions seem. We all have much more power to change the world through seemingly small acts than we intuitively think we do. And at the end of the session, I'm going to show you why. Anyway, unfortunately for all of us, just like the folding piece of paper, it is true that elements of the climate crisis are speeding it up as it develops. So let's talk about feedback loops. So a feedback loop is a situation where something happening affects the chances of it continuing to happen. And a good way to explain this to people is to think about eating. So let's give Mr. Creosote a baguette. So when we eat, it makes us want to eat less. And that's called a negative feedback loop, because acting on being hungry makes us less hungry. But imagine if eating more made us want to eat more, though. That would be a positive feedback loop, and it would end badly. Like Mr. Creosote, we would explode. Positive might sound like a good thing, but it's actually bad. Negative feedback loops are all across nature. We get too hot and our body tries to cool us down, right? Now, as the world gets hotter due to human activity, the oceans have so far absorbed 90% of the extra heat, and other mechanisms have been working to try to cool the world back down as well. But what if the world getting hotter actually started to make the world get even hotter? Imagine if the hotness accelerated the heating even more. Well, this is exactly what is starting to happen and is happening right now. So who knows why burning forests across Australia, the USA, Brazil, Russia, and so on are such a big problem? Who knows why burning forests are such a big problem? What do you think? Okay, so Marco is saying they release CO2, and so is Marcy as well. Yes, okay, so the burning forests release greenhouse gases, which we'll talk more about in a moment, that heat up the planet, drying out forests even more, making forests even more likely to burn. And to make matters worse, healthy forests normally work to extract these greenhouse gases from the atmosphere, but destroyed forests cannot do this. Now you can see why, if too many forests were burning, this would be a positive feedback loop that would get out of control. Now we call the point at which this could accelerate out of control a tipping point. Okay, now for something else. So I know that it looks like we're about to talk about the classic cliche of polar bears, but we're actually going to talk about that ice. So as the world heats up, the melting of ice accelerates. So Greenland's ice is now melting faster than at any point in at least 10,000 years. So in July 2019 alone, an amount of water melted off it that was sufficient to cover an area the size of the UK to a depth of about 2.5 meters. That was in one single month. So who knows why melting ice is a positive feedback loop that's heading towards a tipping point? Who knows why melting ice is a positive feedback loop that's heading towards a tipping point? And Anna is correct that there is also the methane problem, but we're going to talk about something else first. And I'm sorry if you can hear that bleeping in the background. I hope that Zoom's noise cancellation is good enough to get rid of that, but something keeps going off outside. Okay, so Iselene and George are talking about it having a less reflective surface. Okay, brilliant. Yeah, so a useful way to explain this to people is to ask them to imagine if they had these two t-shirts. So one dark in color, the color of the ocean, and one light in color, the color of the ice. Now, which of these would you prefer to wear on a hot day? T-shirt number 1 or t-shirt number 2? Which would you prefer to wear on a hot day? Okay, exactly. So everyone is saying t-shirt number 2. So most people would prefer to wear the ice-colored one because it is much better at reflecting heat. Now, as global ice melts, there is less ice to reflect heat, and so the dark oceans underneath absorb more heat, and the world gets hotter. And a positive feedback loop begins, melting more ice, revealing more dark oceans, heading towards a tipping point. Now, there are many more positive feedback loops with tipping points, and a relatively new one we've discovered is related to the world getting dimmer as a whole. And what I mean by that is that if you were looking at the world at night from the surface of Mars, it would look less bright than it used to. And the main reason for this is that the warming Pacific Ocean is preventing the formation of low-lying white clouds that normally reflect a lot of light and heat. And this means that the Pacific Ocean, just like the Arctic, is now absorbing more heat and getting warmer as well. Anyway, as this course goes on, we will encounter many more tipping points. However, for now, I just want to talk to you about what we're worried all of these tipping points could combine to cause. So I want you to imagine that the world is a boulder, and the further right it gets, the hotter it gets, and the further left it goes, the colder it gets. So notice how in this picture, the Earth wants to get colder. It wants to roll down the hill. And if we left it alone, it naturally would get colder by itself. However, our human activities, like emitting greenhouse gases, are pushing the Earth system hotter and hotter. And if we keep going, then it will eventually get to a point where our planet will start heating in a way that will run away with itself. We call this uncontrollable, accelerating heating situation hothouse Earth. Now, as I said before, it isn't the case that there are only things going on that are heating the world up. Many natural negative feedback loops on Earth are working to try to keep us in balance, trying to cool the world down, which is why there might still be time to turn things around. Now, I say might because the truth is that nobody knows where the top of the hill is. Nobody knows if we're already there, heading for runaway heating. The boulder might already be at the top of the hill and ready to roll down the other side. When politicians and leaders talk about climate targets, these targets are based on educated guesses and models. Nobody actually knows for sure if we've already gone too far. Now, this sounds really scary, and it is, but since we don't know where we are, we have a duty to do all that we can. We must imagine that we are the boulder, teetering on the edge. Everything that we do now, and I mean everything, will make a positive difference for the future. Okay, so now we're going to talk about why carbon dioxide causes the world to heat up. And some of you will already know this very well, and so this bit will be concise and quick. So firstly, what do people mean when they say the word carbon? What do people mean when they say the word carbon? So while you're answering that, I'm just going to say that pure carbon is a solid that's normally called graphite, like the inside of a pencil, or diamond, if the graphite has been compressed at high temperatures. So yes, the inside of every pencil is almost a diamond. On a side note, by the way, there's some crazy stuff that goes on Jupiter and Saturn, where graphite dust and methane floating in the atmosphere turns into diamond rain. In fact, I think diamond rain is the most common kind of rain in the whole solar system. Anyway, so carbon, when combined with other chemical elements, is one of the most important building blocks of every living thing on Earth, like this frog, for example. In other words, carbon is all over the place. However, for some reason, the media has started generalizing the word carbon to almost always mean carbon dioxide. So carbon dioxide is formed when things made of carbon burn or rot or get eaten, like this frog. And it's carbon dioxide that we are worried about. Why? Because it does something strange when it's in the atmosphere. So again, bear with me if you already know this bit. We'll be cracking on soon, but unfortunately our kind of dysfunctional and quite prescriptive education system, albeit rarely the fault of teachers themselves, fails a lot of people. And so that's why we've kept this in the course. Think of it as revision or practice in communication if you already know it. So the light shining on the Earth from the sun heats us up, and we can easily feel that on our skin on a warm day. Now, as the Earth gets hotter, heat then shines off the Earth, and we can feel that with our skin too. If we hold our hand above a hot piece of concrete, we can feel the heat radiating off it back into space. So the carbon dioxide that is collected in the atmosphere absorbs the heat that's trying to leave, and when it releases it, it does so in a random direction. And this means that some of it goes out into space, but a lot of it shines back down to Earth, making it even hotter. It's kind of like a one-way mirror where heat can get in but not out, though that's not exactly the right way to think about it, but it might help as a starting point if it seems at all unclear. Anyway, I've shown you this picture of a baby as if it's a one-way mirror the baby can't see through, but actually this is of course just what babies do. So we call this heat trapping effect the greenhouse effect, and we call carbon dioxide a greenhouse gas. Although this is actually a bit weird because greenhouses work a bit differently as well. Anyway, at this stage, you might be wondering why this effect only happens when the heat is trying to leave, but not when the heat arrives. And it's because the heat leaving is slightly different to the heat arriving, and we can talk more about that in the Q&A if you're interested to know more. Anyway, the greenhouse effect results in global warming, now increasingly being called global heating, as that's a much more suitable name considering how quickly it's happening. So there are many more greenhouse gases than just carbon dioxide. Which one do you think is the strongest? Which one do you think is the strongest of all the greenhouse gases? So I can see that Ray is saying methane, Haley's saying methane as well, says Leia. There's one called carbon tetrafluoride, which is especially bad, but thankfully there's not too much of that one about. But yes, so methane is the big one, like many of you said. Methane is about 90 times stronger than CO2 when measured over 20 years. But it's only about 30 times stronger when you measure over 100 years. And this is because it naturally gets removed from our atmosphere much faster than CO2. Different businesses, organizations, and countries will often use this difference to try to shift blame onto one another. They'll measure over 20 or 100 years, depending on which is more convenient for them, whether they're emitting more CO2 or emitting more methane. So that's something to be aware of. But anyway, yes, so methane is one of the biggest culprits of global heating, with a recent study putting it level pegging with CO2 in its human-caused heating effects. However, CO2 also lasts a lot longer in the atmosphere. So it's generally been carbon dioxide that we've been worrying about most, though we are now finally starting to worry a lot more about methane. Anyway, here are some mammatus clouds, which are really beautiful, rare ones that look like giant grapes in the sky and occur around thunderstorms. Now, the truth is that actually up to 70% of the greenhouse effect is caused by water vapor, as Amna said, because it's such a strong greenhouse gas and there's so much of it in the sky. Now, water vapor is another potential tipping point because more heat means more evaporation of the ocean, which means more water vapor, which means more heating. The reason the global conversation isn't about water vapor, though, is because it's not something we can control. It's just something that responds to the rest of the whole system. What we can and must control is carbon dioxide. Now, as an aside, it's a common myth that goes around in some parts of the world that global warming is being caused by heat getting in through holes in the ozone layer. The ozone layer protects us from cancer-causing UV radiation from the sun, and that is a whole different story. Anyway, so it might seem like bad luck that we have an Earth that heats up so easily, but it's actually really important. The greenhouse effect is not a problem. So who knows what the average temperature on Earth would be without the greenhouse effect? Who knows what the average temperature on Earth would be without the greenhouse effect, roughly? And guess if you don't know. Rob is spot on with -18 degrees C is what we think it would be roughly. So also the temperatures would be more extreme, with an enormous difference between cold days and extremely cold nights. With the greenhouse effect, the Earth averages about 15 degrees C. So we need the greenhouse effect. It's not a problem in itself. Throughout the history of our planet, we've not only had the greenhouse effect, but also the levels of different greenhouse gases have changed. And it's natural for them to do so, and natural for the temperature of our planet to have changed as well. The problem isn't that levels of CO2, methane, water vapor, and so on are going up. The problem is how quickly they're going up, and how it could trigger difficult to reverse or maybe impossible to reverse changes if the rock rolls over the top of the hill. Some people point to times in the past when the levels of greenhouse gases were much higher, and they say completely correctly that life got by just fine. And they use it to cast doubts on whether climate change is a problem. And of course, what they're missing is that it's the speed of change that matters. So I want to show you something that you can show to other people. So you can represent the climate of the world with a piece of paper. So if you have a piece of paper with you, then do give this a go as well. So as we add more greenhouse gases to the atmosphere, we can represent this by moving more of the paper above our fingers. And we can continue to do this for quite a while, and there'll be no consequence. The climate system remains stable as we put more carbon dioxide into it. However, there eventually comes a point where the piece of paper and the climate changes very rapidly to a different state, like a hothouse Earth. Now, what do you think would happen if we now tried to go backwards, to reverse this collapse by moving our hands back up the paper? What will happen if we go backwards? So you might think, yeah, as Jen is saying, it's lots of struggle. You might think that we can easily now move more of the paper below our fingers and immediately undo this, but this isn't the case. In fact, once we get too far, we have to go a really long way back to return to the state we were in before. Now, of course, the climate is simpler than a piece of paper, and it may never be possible. The climate is less simple than a piece of paper, and it may never be possible to go back to where we were if we go too far. As stewards of this planet, we have to be very careful. We don't want to be the generation that allowed this to happen on our watch. Now, of course, this course promised you solutions and empowerment and to not focus on what's going wrong, and that's where we're going. But to get there, we have to go through the reality of where we are now and where things are heading. So you will already know that there are worsening droughts, floods, hurricanes, the displacement of millions of people as crops fail, and that over a million kinds of living things are on the brink of extinction. And all of this can be very overwhelming. It is really distressing to see the reality of what is going on in the world and to be a part of the people who understand how much we need to change and how little seems to be getting done to turn things around. And it's okay to mourn. It's okay to be sad, and it's okay to be angry. Many of us are there with you, and we have to show that we are there for others as well. However, we also mustn't feel hopeless, because hopelessness really gets us nowhere. Hopelessness is something that is forced upon us by a dysfunctional system, and we have to shake it off. In the words of the great Jane Goodall in one of our first ever AimHi sessions, every one of us can make a positive difference every single day. None of us wanted to be born into a time when there's a climate crisis unfolding. May you live in interesting times, as the old curse goes. But this was not our choice, and we all have a role to play in turning this around. By working to become more effective leaders and communicators, we have the chance to multiply our positive impact many times over. So thank you so much for coming to this course today. So I want to share a story with you now about these ladders and this ladder and these monkeys. So a load of monkeys are in an enclosure, and at the center of the enclosure is a ladder with a load of delicious bananas at the top. Now, every day the bananas are replaced with fresh new bananas. But one day, some humans decide to set up a perimeter around the ladder. Now, if any of the monkeys cross the perimeter, then cold showers are activated all across the enclosure, and all of the monkeys get wet. And the monkeys don't like this, and so they start attacking any monkey that goes near the ladder. And very quickly, all of the monkeys learn that no one is to climb the ladder for fear of activating the cold showers. So next, over a period of time, the monkeys are replaced one by one. And each new monkey learns, each new monkey learns from the other monkeys that it shouldn't climb the ladder, even though it's never experienced a cold shower, and so doesn't know why. Eventually, all monkeys have then been replaced by new monkeys, none of whom have ever experienced a cold shower, but they have all learnt to attack other monkeys that go near the ladder. The humans then turn off the perimeter and the cold showers. What do you think happens next? What do you think happens next? So as Agnes says, yeah, no monkey takes a banana. So for a long period of time, monkeys continue to attack one another for going near the ladder, even though it no longer makes sense to do so. Now, eventually there will be pioneers, creative monkeys that will experiment and find that the old rules are better broken, but it could take a long time. Now, this experiment wasn't ever carried out exactly as described, but similar experiments have shown how normal it is for living things, including humans, to adhere to ingrained normalities, to do things because that's how we've always known them to be done. I mean, think about it. Why do we wear ties, for example? It's such a weird thing that we do. We are wired to accept our present reality, to put our trust in the status quo, even if it doesn't quite make sense to do so. Many of the biggest problems in the world exist, not because we don't know they're damaging, but because we're so used to the way that things have always been done that we struggle to imagine how they could be different. Now, understanding the limits of human psychology is just as relevant for understanding and communicating effectively about the climate crisis as any graph of CO2. Why? Because the climate crisis is not just a science problem, it's a perception problem as well. This is why good communication is so crucial, by helping those around us to question the way that things are done and to imagine how they could be done differently. By doing so, we can create change very rapidly. Ideas are really powerful things, and we'll talk more about that in a moment. But first, I'm going to show you some quotes compiled by AimHi Earth's friend, Dr. Emily Grossman, in her book, Emergency on Planet Earth. And Marco, I will try to remember to wear a tie to the next session. It is agreed. Okay, so I want you to tell me if you recognize the names or associated organizations of the people saying these things, because this is our current reality, but it doesn't have to be. Now, in case you'd like these quotes, by the way, we'll give you these in the pack after the session. So this is an emergency, and for emergency situations, we need emergency action. Ban Ki-moon, former UN Secretary General. Now, these are very prominent people from prominent organizations. Agnes recognizes 3 of them, involved in influencing global decision-making. Yet somehow climate is still a long way from being the world's #1 priority, still dwarfed by the arguably much smaller COVID-19 crisis. Now, COVID-19, of course, changed the world almost overnight, yet we are repeatedly told that making the necessary changes to turn around the climate crisis will take many years or even many decades. So the sessions in this course will cover many of the solutions to the climate crisis. For now, though, we are going to start with just one. We're going to start with the simplest and most effective of them all, and it starts with a question. So, what percentage of human-produced greenhouse gases do you think come from energy production? What percentage of human-produced greenhouse gases do you think come from energy production? So Andrew's saying maybe 30%, Susan's saying 50, Alison 15, and Bella's going for 60. Okay, so the answer is over 70%. So the majority of it is coming from energy production. If you'd like to know what the other sections are, then green is agriculture, blue is waste, and gray is industry. All of the energy from those 3 things is included in the big red energy slice. So industry is mainly things like cement and chemical engineering and so on. So yes, over 70% of this is energy. So what percentage of global energy do you think is generated by burning fossil fuels? What percentage of global energy do you think is generated by burning fossil fuels? Rachel's saying maybe 80%, Carrie's saying 80. And yes, it's around that. So the answer is about 85% of global energy is generated from burning fossil fuels. Now, burning fossil fuels releases CO2, among other pollutant gases, which leads to global heating. So this is a graph of the CO2 level in the atmosphere since the year 0 AD. Now, you might be wondering what ppm means, and if so, then it means parts per million. So 400 ppm means that there are 400 particles of CO2 in every million particles of air. Now, this might sound small, but only a small amount of CO2 has a big effect, which is why it's such a problem that this is what has happened since the Industrial Revolution, when we started burning fossil fuels on a huge scale. In the words of NASA's Dr. Michael Funson, the world is quickening the rate of accumulation of CO2 and has shown no signs of slowing this down. Now, I'm wondering if anyone knows what percentage of all human-caused CO2 emissions from fossil fuels occurred in your own lifetime. For anyone on here who is 15, it's about 30% of all emissions from our burning of fossil fuels that have occurred during your lifetime. If you are 30, it's over 50% of the emissions. If you're 50, it's about 75% of them. And if you are 85, it's more than 90%. Now, why have so much of the emissions occurred so recently? It's because this is a now problem. We are burning fossil fuels at our fastest rate ever right now. As of 2021, we were subsidizing fossil fuel production to the tune of about $11 million US dollars per minute, 11 million US dollars every single minute. Okay, now I want to show you what the CO2 level has been like for the past 800,000 years. Now, the way we found this out is actually really cool. So every year, air gets trapped in the Antarctic ice as it builds up each winter. And it's true that some of this ice melts the following summer, but some always remains and gets buried under more new ice the following year. And so the deeper we dig into the Antarctic, the older the air that's trapped inside the ice gets. And so the deepest, oldest air still in there is about 800,000 years old. So we call these Antarctic ice air records ice core data. And this is what one of those ice cores looks like. We can easily see that there's different kinds of air frozen into the different layers, which I think is really cool. These ice cores are so accurate that we can use them to figure out when the Romans started using slightly different mixtures of metals in their coins. Isn't it really amazing that we found so many historical secrets in Antarctic ice? Anyway, as you can see, let's sweep that aside. As you can see, the CO2 levels have certainly moved around quite a bit over the past 800,000 years or so. But it's also not moved anywhere near so much, so high or so quickly as it has in just the, I moved it off the edge. Here, let's bring that back. As it has in just the past 200 years. It's happened so fast that you can actually hardly see it on this chart. Now, you might sometimes come across arguments where people say that recent global heating has nothing to do with greenhouse gases, and it's actually a consequence of natural solar cycles and that the sun is currently getting hotter. Now, the internet often perpetuates things that aren't true because people share stories that sound compelling. The sun is actually getting less hot and has been for the past few decades, and we'll send you the data showing this in the pack after the sessions. Now, who here thinks that oh, sorry, that was what I was going to ask you. Who here thinks that people who believe these things are stupid? Who here thinks that people who believe these things are stupid? Okay, so a lot of people are saying not stupid, but just misinformed. Yes. So at AimHi Earth, we think that they rarely are, and we don't think that treating them as stupid helps very much either. These are people who like questioning conventional wisdom. Many of them could potentially be good scientists with a disposition for questioning things. Now, it's important that we don't forget how compelling many conspiracy theories are for people and how difficult it can be to sort fact from fiction once our trust in scientific institutions erodes away. And we'll talk more about that in session 4. But for now, though, I want to say that it can be exhausting trying to convince climate change skeptics to change their minds. But the best path is always with kindness, understanding, a lack of judgment, and above all, patience. Now, luckily, these people are rapidly becoming less influential in the world. And so most of the work we have to do isn't actually convincing a small number of deniers to change their minds. It's in convincing those who already know what's happening that we need to act with much more urgency. Our role, if we're going to be effective leaders and teachers and communicators, is actually almost all about empowering and compelling people to take more positive actions faster. Okay, so now we don't want to overdo the charts, but I want to show you just one more. So we're now really zoomed in on just the last 20 years. So what do you think is causing this wobbling? What do you think is causing the wobbling that is going on here? Now, don't worry if this is now too much detail for you. The main thing we're going to talk about is the fact that it's still going up. And while we wait for answers, I'm just going to show you this image of a sea slug called, oh, I'm going to try and show you this image of a sea slug. I'm going to show you this image of a sea slug called Elysia chlorotica that can photosynthesize like a plant. So it can just kind of sit in the sun and make its own food without doing anything, which I think is really cool. Anyway, moving that out. So yes, as Alison says, it's to do with seasons, and Rob is spot on as well. So yes, the wobble is because every year the summer growth of plants and sea slugs, I suppose, decreases the level of CO2 in the atmosphere. And then the winter death of plants increases it. Now, this is mainly driven by the plants growing on the landmass in the northern hemisphere, since there's much more land in the north than there is in the south. Now, this is also sort of a teaser to what we're going to talk about in part 2, that nature is one of our most important climate solutions, and that a healthy natural world is critical for carbon dioxide being removed from our atmosphere. Anyway, so notice how the level of CO2 is continuing to rise. CO2 did not fall because of the pandemic. The rate of increase may be slowed a little, but the overall level is still increasing really fast. Now, just a moment ago, we saw how rapidly the CO2 level is rising relative to the last 800,000 years. However, we have reason to believe that our atmosphere has likely not changed as quickly as it is doing now for hundreds of millions of years. In fact, 252 million years ago, a rapid change in the atmosphere resulted in the permanent disappearance of up to 96% of all the kinds of living things in the ocean, and around 70% of all the kinds of living things on land as well. Many people aptly call this the Great Dying. Now, history never repeats itself, but it can rhyme. So some people like to think that we might run out of fossil fuels in time to be saved from them. We're all taught in school that there's a limited supply, but actually the predicted amount of oil left to extract on Earth goes up by about 2% every year, because we're discovering new reserves even faster than we're using them up. There's no two ways about it. We need to stop burning the fossil fuels that are creating all this CO2 as quickly as possible, from petrol and diesel to coal and natural gas. This is our most important solution, and it is very simple. Just because the world has been powered by fossil fuels for so many years doesn't mean for a moment that it has to continue like this. We don't have to be monkeys around a ladder, especially when doing so has us on a collision course with catastrophe. We can and we will devise a new way, and here's how we can start as a planet. Number one, switch to greener sources of energy generation, so solar and wind and wave and so on. Despite what people say, we can power the world without fossil fuels if the will is there to make the changes, and there's recognition that the short-term expenses to make it happen are actually enormous long-term savings. And two, reducing global energy use overall. A lot of the ways that we use energy are unnecessary and inefficient, and we could be a lot less wasteful. So how do we have a positive impact ourselves? It's easy to think that we need to be in a formal position of power to make some kind of significant difference, but that's not true. We can start right here where we are with what we have. Now, I want to first acknowledge before I run through this list that some people don't have the resources or freedom to make the choices in this list, but for those who do, these are some of the most important things that you can possibly do. So firstly, move any money we have away from banks and pensions, etc., that invest in fossil fuels. Most banks and pensions still do invest in fossil fuels, so do your research. I bank with Triodos, they're quite good. Our friends at Make My Money Matter recently found that for people in the UK, moving a pension is 21 times more effective for reducing carbon emissions than going vegan, cycling everywhere, and recycling properly all combined. Now, we are a little bit uncomfortable about this number because we shouldn't be counting everything just in terms of carbon emissions, and we'll talk more about that as sessions progress. But the number certainly paints the right kind of picture of how positive it can be wherever we may be in the world when we move our savings and pensions. If we're lucky enough to have money, we ought to be responsible with it. Now, next on this list is, in democratic countries, we can all vote for political parties that actually treat the climate crisis as the existential emergency that it is, and consequently their top priority. Most political parties do not do this. Next, we can vote with our wallets and find a way to pay that little bit extra for energy generated from renewable sources. In Switzerland, all energy companies now make renewable energy the default option when making choices online. People have to actively choose to switch to a more polluting fossil fuel option. Now, before Switzerland did this, only 3% of Swiss citizens selected renewable power. Now more than 80% do, even though it's a bit more expensive. More renewable energy means less fossil fuel energy, and so this makes a huge positive difference for the world. So let's spread Switzerland's idea. Let's try and make green the default option for every offering proposed everywhere. And finally, last on this list is if we ever fly, we can fly less or not at all until electric planes arrive, or perhaps slow-moving, energy-efficient airships with comfortable cabins and good internet. Now, the irony of flying is that as the greenhouse gases pouring out of jet engines cause the world to heat up, turbulence also gets worse and flights get more dangerous. This is because of increasing tension between a hotter troposphere and the cooler stratosphere above. It's almost as if the world is trying to kick us out of the sky. Anyway, you might notice that there are some key missing points from this list, and they are coming up later, hopefully, the ones that you might feel are missing. Anyway, the danger with this kind of list is that it might sound as though I am saying that we must all take it upon ourselves to combat the use of fossil fuels individually. Now, as vital as individual change is in creating positive, often huge unseen ripple effects, our overall system won't transform fast enough if we only make changes driven by varying levels of understanding and guilt. And it also doesn't feel very good doing so either. Now, if you think about it, it's actually quite absurd for a government to do little itself to combat the climate crisis and to act as though the solution is to get people to make their own decisions and hope for the best. It's sort of like telling the population, okay, we're getting rid of all the laws about stealing and we're getting rid of all the police, but stealing is bad, so don't do it. Now, we know this doesn't work, but nevertheless, a lot of governments and companies are jumping on the bandwagon of encouraging the public to count our own carbon footprints, and it's effortless for them, and it conveniently shifts the responsibility away from them. Now, whilst it's true that every little helps, it's also really demoralizing to do all that we can as individuals whilst massive corporations pour out our entire lifetime of emissions in a few seconds. But this is why we shouldn't ever motivate ourselves on the basis of the amount of carbon we're each saving. What's much more important is that our individual actions, whether at home or in work, make us part of a growing movement of people all around the world who are changing what normal means to a normal that's informed by the scientific reality. We are nudging the behaviors of everyone by contributing to a cascade that's fundamentally altering the landscape of what is and is not acceptable. The more of us there are, the faster the world changes. We need thousands of us, and then we need millions of us, and then billions, nudging people from being passive spectators to being here on the team with us. Together, we are the pioneering monkeys around the ladder, imagining new, better ways to live. Now, of course, we need governments to make laws that make it impossible for the climate crisis to continue as soon as possible. But how can we do this if we don't run governments? Now, some governments are starting to slowly move in the right direction. For example, China has announced that they will emit net zero carbon from 2060. So net zero means that they still plan to emit greenhouse gases, but they then plan to find ways to absorb them also. Now, is anyone here skeptical of net zero? Is anyone skeptical of that as an idea? Penny is saying yes. So Samuel. So net zero is actually quite a questionable idea, partly because every year until we get there, we're still adding to global heating, and partly because it doesn't have an answer for the emissions that we've already released. But mostly because of even bigger problems with it, which we'll talk about more in session 4. However, for all its faults, it also has some importance because it's one of the few things that governments are aligning on at the moment, and momentum is building behind the UNFCCC's Race to Zero campaign. And so at AimHi Earth, for now, we think of net zero as something that is a long way from perfect, but is still worth our support, provided we're clear that we also need to do much better, much faster. An increasing number of countries have a net zero by 2050 target, including the UK and New Zealand. However, the best evidence suggests the 2050 target could be too slow and put us at significant and unnecessary risk. The boulder could already be at the top or beyond the top of the hill by then. Even if we manage to halve all emissions by 2030, it could be too slow. Another way of looking at these recently announced half emissions by 2030 targets is that governments are openly telling us that at the end of the decade, we will all still be emitting more than 15 billion tons of CO2 every year. Now, there are a few countries on target for a reasonably low level of emissions: the Gambia, Costa Rica, Suriname, Bhutan, Kenya, but most are miles behind. And meanwhile, the CO2 levels that we've been thinking might warm our planet by only 2 degrees C by the end of the century are starting to look like they could cause up to 4 degrees C of warming. And we'll talk more about global temperatures in session 4 as well. Now, a few degrees of warming might not sound like a lot to many people, but nature says otherwise. Increases in CO2 so far mean that 80% of the Great Barrier Reef has bleached, so is on the verge of dying since 2016. People sometimes say that climate scientists are alarmist, but it's the exact opposite. Their estimates and models are almost always very conservative. So how do we catalyze even faster change? Well, we teach one another. We spread knowledge. We use what we know to empower everyone around us. We are living through a crisis of imagination. There is so much potential for things to change. And we have focused on one key solution today. And the next sessions will show you many more, many with very easy steps we can all take to help them to be realized. We are living through a scary time, but also a very exciting time. Things are moving and we need to be a part of that change. Even Ariana Grande is making songs about climate now. And in 2021, the keyboardist from Foals quit the band to focus on climate. People are changing their perceptions, and it's up to all of us to accelerate this rising tide together. It's really easy to think that we can't make a difference as individuals, but our seemingly small actions and communication of knowledge and ideas can be very powerful. If one single person thinks of an idea and shares it with just 3 people and then stops sharing it, and then the next day, those 3 people share it to just 3 people each, and then they stop sharing it. And then the next day, those 9 people share it to just 3 people each, and so on. How long would it take for the whole world to know the idea? This is assuming that everyone always tells a new person. So P. Graffman is saying 1 year. It would be just 3 weeks. It's even faster if each person shares it more than 3 times. We have agency over our own future, and collectively we are stronger than any seemingly unchangeable inertia, especially if civilization depends on it. So please go forth and spread this knowledge. I want to finish on this quote from Muhammad Ali as a teaser for session 2. So looking at life from a different perspective makes you realize that it's not the deer that is crossing the road, rather it's the road that is crossing the forest. So thank you very much for coming, everyone. In a moment, we'll move to the optional Q&A. So please do start adding questions to the chat now if you'd like to. But before we get there, do take a moment to let all of this sink in and think about how you can apply what we've learned today to your own life and work and plans. And think about what one thing you can share with someone else, and be the ripple effect by making sure you share it. If you enjoyed this, then please recommend AimHi Earth to your friends and colleagues in places of work and world leaders and so on. There are links to share our courses via your after session packs. Session 1 as well is running again this Sunday, so it's not too late for others to begin this run of the course. The link is the same for every session. So if you have any problems with your internet on this run, please feel free to join the Sunday run if you'd like to. You can also watch a full recording of session 1 on our YouTube channel by searching AimHi Earth, or just by clicking this link if you'd like to. This video is public, so please do share it with others too if you'd like to. That said, this full course is modular as well, so it's possible for others to start on later lessons and not to feel at all disoriented. We'll also be running this whole course again before too long, and it'll be possible to book onto that very soon via our website. Word of mouth multiplies like folding paper, so please do help us to change the course of history by getting as many people through our climate and nature courses as you can. Here is the best link to share if you'd like to share with other people. We also run tailored courses for big organizations and institutions. I'll talk more about those in a later session as well, though for now, if you'd like to find out more, please write to us on this address or visit this page. I'll just drop those in as well. Also, as I said at the beginning, if you're one of the people who's signed up for this course from a climate communication organization, we saw a few of you on the guest list, please get in touch with us if you'd like to collaborate. For now, some things to look forward to. At the end of this course, as promised, we will give you a certificate of completion. We will also explain what this certificate means. Also, if you'd like to join me on Friday at lunchtime, 12:30 p.m. UK time, we are running our Keep Calm and Ask on Fridays sessions. You can access them via our Facebook page or via this same Zoom link. We'll run them on the same Zoom link. You can access them from either. We'll also post reminders on all our socials, so follow us on whichever of those is the best for you. These sessions are a safe space for you to bring any question about the climate and nature crisis or how to talk about it, and we'll do our best to get everything answered. And if we can't answer anything, we'll work to bring in a relevant expert the following week. So Keep Calm and Ask on Fridays runs every Friday, and it's open to everyone, so please do let others know. Very soon, you will receive an email from us containing a link to your after session packs. If you're a teacher, then you'll also be able to access a pack specifically for teachers. These packs give you positive actions that you can take right now and longer term, inspiration for starting courageous conversations, notes, references, and some of our top links. We'll also send you a really short quiz so that you can test how much you've learned. Do give it a go if you'd like to. And lastly, if you'd like to join our community on Facebook to mingle, ask questions, share ideas with other AimHi Earthlings and so on, then this is the best link to do so. Our experts frequent this community to answer complex questions if members on there haven't already given great answers already, as they often do. And it's also the best place to get updated resources from us fresh off the runners. And perhaps most excitingly, actually, is that the AimHi Earthling community has just launched a book club. which we'd encourage you to join. I believe that the staff of Patagonia Europe are joining the club too, so you can make friends with them as well if you'd like to. So please tell your friends, family and colleagues about our Education to Action organization and our mission to activate millions of nature first thinkers to build the future we all deserve. Please do follow our socials. All of them are AimHi Live, and sign up to the AimHi Earth mailing list via our website if you haven't already. You can also donate to support us via our website if you'd like to. If you make any social posts about this course, then please do tag us with the hashtag if you're a hashtaggy type person. So yes, thank you so much for being a part of our Climate and Nature course part 1. For those unable to stay for the Q&A, we will see you next week. Thanks so much for coming, everyone. Thank you. Okay, so questions, right. Are there any questions? Let's go back to this view. Okay, so Tommy is asking about the difference between heat entering and leaving. So it's to do with wavelength. It is a it's a longer wavelength when it tries to leave, and that's a wavelength that so the vibration of the light is a wavelength that the CO2 just absorbs more easily. It's like I was saying, you could in some ways think of this as an unfortunate thing, but actually it's very fortunate because it allows the world to be warm enough for life to have developed in the first place. So yes, it's to do with it being slightly different wavelengths on the way in and the way out. Amna is saying, can I please clarify, should we be aiming to go net zero or carbon neutral? Okay, so in many ways, the two are basically the same. So net zero means that you're emitting as much carbon as you're releasing, and carbon neutral means essentially the same thing. But yeah, as Expiry Matters has just said, carbon negative is a much more important concept. So at the moment, we're kind of being sold this idea by the well, a lot by the fossil fuel industry that we will be okay if we just get our carbon emissions down to 0 by 2050. But what that means is that we're going to carry on emitting for a huge period of time until we get to that point. And actually, we need to be thinking a lot more about how can we draw down emissions, and how can we store them in nature and other forms. So aiming for, this is something that rather than going into this in a large amount of detail, this is something that we're going to talk about a lot in session 4. So do come along to that one. Okay, so Toby is saying, what is a good way to respond when people say global heating is naturally occurring, would have happened anyway? Many of my friends hold this view. Okay, so this is I think that there's a big problem at the moment with the internet being the way that it is, in that we've kind of set up this incredible space in social media where everyone is sharing all these ideas, and some ideas are incredibly sticky to some people and they spread very, very quickly. And so I think that maybe if your friends are thinking that, Toby, then it might be hard for you to present a load of evidence to them and get them to respond to the evidence. And so it might be a better route to take to talk about the kinds of ways that misinformation spreads online, and to maybe go to one of the best websites is Snopes. So Snopes is this website that finds things that get posted repeatedly online and then tries to track down whether they're true or not, and maybe pointing out how many of the things that spread very quickly online are false could be a better way through that problem. Because often when people hold very strong views about climate change being natural, it's not necessarily because they don't have access to the right information. It's because they are choosing to prioritize the information that seems more compelling. That's a really natural thing to do. You know, it's totally normal for humans to want to read the more compelling form of information. Okay, wait, so I'm going back to a question that came in earlier. So Camilla or Camila, and I'm sorry if I'm pronouncing that a little wrong, but you mentioned China's manufacturing output a few times, and how China is a big contributor to global emissions. So it's true that the way that emissions are counted at the moment, China is the largest emitter. But actually, if you start to kind of, it's a strange thing, because What's a bigger problem? Is it a bigger problem if China is producing goods that release emissions, or is it a bigger problem if, say, the United States is buying them? Who's the one that's more to blame in that relationship? Perhaps they're both equally to blame. But the thing is that China being the biggest emitter, is a lot of it is being driven by other nations that are buying things from China. So that's one point. But actually, the more important point is probably cumulative emissions, which is something we're going to talk about again in session 4. So I don't want to go into it too much. But basically, since CO2 lasts in the atmosphere for such a long time, the CO2 that was emitted in like 1910 is still a problem. Most of it is still a problem for us. And so when we're looking at the amount of CO2 that's emitted, it's actually better, in my view, to look at the total amount of CO2 that's been emitted historically. And if you do that, then the EU and the USA have emitted far more than China. So that's not to say that China doesn't need to reduce emissions, because of course China does. But it's just to say that there is perhaps greater responsibility with those who've emitted more and profited and benefited from doing so in the near term. Anyway, I'm going to skip down to some other questions. Also, yeah, Rob's pointing out that China, I don't want to say that China's a climate leader, because they're obviously emitting so much carbon dioxide, but it is important to note that China has actually been putting a lot more investment into technology to turn things around than the EU and the USA, for example. They have far more high-speed rail, far more development of wind farms and solar power than any other region. It's one of those things that goes around the internet that kind of says, well, we're not doing anything because China's not doing anything, but actually China's doing loads. And so I think we need to start thinking as a united global unit, rather than just kind of picking out who we think is doing the worst and using that as an excuse to not act ourselves. John's asking, what removes carbon dioxide from the atmosphere? Okay, so John, that's something we're going to talk about a lot in session 2. So I'm going to not answer that immediately. Although actually, maybe I will. I'll answer a bit of it, because there's a really cool mechanism that we won't talk about in session 2. But so there are these cool little creatures called copepods that live in the ocean. There are loads of them. There's so many of them that their daily mass migration from the bottom of the ocean to the top actually moves more water than the moon. So they're a pretty amazing creature. But anyway, they come to the surface every day, and they, what do they come up at night? I don't know when they come up actually, but anyway, they come up once in the daily cycle, and they eat loads and loads of these kind of little bits of algae that have been growing during the day. And when they do so, they poo out loads and loads of the material, and that poo then falls to the bottom of the ocean, where it gets covered up in sand. And so, and then hopefully gets stored there for a long period of time. And that is one of the mechanisms that removes CO2 from the atmosphere quite quickly. It's due to nature. You might have heard that whales are responsible for removing loads of CO2 from the atmosphere as well. There's a similar mechanism. Obella's mentioning that there. But yeah, we'll talk more about nature in the next one though, so I'm not going to go into that too much. Okay, so Marlene's talking about, should we be measuring emissions per head and not per state? And again, that is another important point, is that when we look at just the emissions of a single country, it's easy to look at the countries with huge populations and say, well, they're the most to blame. But actually, I think that ultimately so much of the climate and nature crisis, whilst I came to it from a scientific perspective, so much of this is just about fairness. It's just about fairness, which is such a fundamental human thing that surely we can try and get right. And one of the things that is really unfair is that some countries have ridiculous amounts of emissions per head. So yes, China might be emitting more in total, but the USA per head is emitting far more. So is Australia, so is Saudi Arabia, and so on. And that's, again, something that we'll talk about more in session 4. Okay, and Toby was asking, when I was talking about solutions, why did I put flying on the list instead of general transportation? Is it the worst? And yes, flying is significantly worse than other forms of transport like trains and buses. Even driving, flying is significantly worse. In fact, if we take the UK, and I know that the UK is just one small example of the whole world, but If we take the whole of the UK, then many people who fly a lot will emit the entire year-long emissions of some of the people in the UK who don't fly very often. They'll do so within just 1 or 2 flights. So for those in the UK who fly regularly, they're basically like taking the carbon footprint up of whole families of people who don't fly very much. So yeah, flying is very, very problematic. There is technology being developed for electric planes, and I also mentioned earlier about slow-moving airships. I think that, I mean, increasingly work is online, and I know that not everyone is able to work online, but for those who are, imagine if we had slow-moving airships with really good internet connections that you could just travel around in with barely any overall emissions impact. That would surely be a much better option. You wouldn't really mind if you were on there for a few days, if it was a really comfortable place to be where you could get on with what you need to do. Rachel is asking, what do you think is the best way to explain this to young children, a simplified version of today? So that's quite a broad question, and it depends how young you are asking about. So we find that kids as young as 11 or 12 quite enjoy these sessions. And maybe we've had kids as young as kind of 8 or 9, but below that age, I think that one of the most important things, which we'll again allude to more in the next session, is telling the story around nature, because actually the climate crisis is just a subsection of the nature crisis. The reason that we're worried about the climate crisis is because it will upset the balance of nature if we let it get out of control, and that will collapse our food systems and all the other systems that we depend on to breathe and to create medicines and so on. And so for children, whilst the story is very big and has lots of different ideas in it, I think the best way to talk about it is about the importance of nature and how much of nature has disappeared and how much it needs to be restored if we're to be safe, and that anything that is destroying nature, like a heating world, is something that is going to be problematic. Okay, Ray is talking about the Ministry for the Future, which is the book that the book club is just doing at the moment, I think. So do join the book club via the Facebook link, which I put above. I'll just drop all the links again here in case anyone would like them. There you go. So yeah, join our community. That link is where you can access the book club from. Mariam's saying that the method of farming can make a big difference on CO2 emissions. Is that true? That is what session 2 is all about. It's about farming and food as the main focus. So I'm going to delay until that one. Also, it's nice to see you here. And so what else? There are so many questions here. Sorry, I'm not keeping up as much as I could. Rob is asking, has there been any research into how much heat is transferred out of the atmosphere by the process of evaporation and then condensation in the higher levels of the atmosphere? I don't know the answer to that one. So sorry, I've just read that one and I will try and find out, but you can also pop that question on the community. We can get that answered for you there, but I don't know the answer to that one off the top of my head. And Sonia is talking about, should we not make a better use of social media to make climate-friendly actions more trendy? And that is one of the main things that we are working on as a project. So we, as an organization, we operate with a lot of projects that are basically, we decide what projects we're going to work on the basis of the positive impacts that they can have, rather than on any other metric. And obviously we have to balance the books within that, but ultimately we decide things based on how much we can help to shift behaviors in the right kind of direction and help to enable and empower people to be both great communicators and people able to make good choices and lead and so on. And making climate friendly actions more trendy is one of our big projects that's coming up. So let's see what else there is. Okay, so P. Graffin is talking about what can you say about the permafrost melting and some projects like Pleistocene Park. So I don't know about the Pleistocene Park project, but permafrost is a really, really big worry. So for those who don't know, there is a huge amount of land in mainly in the northern hemisphere that contains areas of ice and frost that have been like that seemingly permanently. So we call it permafrost. Now, a a lot of this ice developed in times when the atmosphere was different, and also other mechanisms have worked to result in this ice containing a ton of like ton is way more than a ton, ridiculous amounts of methane. There's huge amounts of methane in this ice. And so one of the things that, like I said when I was talking about the boulder at the top of the hill potentially rolling off, and how we don't actually know for sure where we are, the permafrost is one of the big factors that means that we may be much further along than we might like to think that we are. Because if that melts, it will release vast amounts of methane that will heat the world very, very quickly. One of the things we know from looking back into the past is that often rapid events in the atmosphere change due to quite unexpected circumstances, and well, we most often can't figure out what the change is caused by, and it's often something that kind of seems to be triggered and then run away with itself. So a tipping point, as we talked about before, and I think the permafrost, the methane and the trapped in the permafrost is something that is very, very worrying. It's one of the things that I worry about the most. So yes, I'd like to know about the Pleistocene Park project there. It's about reintroducing big mammals to prevent the soil melt. Cool, that is so interesting. Thank you, I'm gonna write that down. I've just captured that so that I can think about that later. So Adrian is saying, on your list of personal actions we should take to stop climate change, where does insulate your house come in? Okay, so that is another good one that is not on that list and possibly should be. I think that insulating our homes is something that is potentially very expensive. And so it's one of those things that my personal belief is that governments should get a lot more involved in funding that kind of work to be done, because a lot of it might involve taking down walls and things like that. Certainly, I know that the government's involved in better loft insulation grants and so on, but I think that they need to do much more. Okay, Tim is saying, has anyone actually done the numbers and concluded if we can reach under 2 degrees C of warming? So Tim, the answer is that people are constantly working very hard to try to create models that are as accurate as possible. But ultimately, as I was saying before, nobody actually knows for sure. It's impossible to know for sure because we don't know all the information. We don't know what mechanisms might kick in to try and slow things down or speed things up. So it is an unknown thing. But that's why it's so important that we act as if we are in the highest possible state of emergency, because we may be there. And if we don't act like that, then we're putting ourselves in huge amounts of risk. So I think we need to think of this. It's very important that we think about this whole situation less in terms of like temperatures on a thermometer scale, and a lot more in terms of overall risk. And we are currently in an extremely risky situation. Continuing to emit greenhouse gases until 2050 is, to my mind, from the numbers that I've seen, seems woefully insufficient, and needs a lot more ambitious targets. Anyway, okay, so N, mysterious, just N there, is asking about how can we really put CO2 back if most of it comes from oil and coal, and that is something that we talk about in session 4. And Sonia was asking about, isn't the largest uncertainty around the future warming given by unknown evolution of greenhouse gas emissions? So I don't know if that's the largest uncertainty, but it is one of the biggest uncertainties, is being unsure about how greenhouse gas emissions overall will change, dependent on how the different parties involved respond. Okay, what other questions are there? Sorry, I know there were loads back here that I missed. Haley was asking for a reminder about the stat about shifting your pension being more effective than shifting to a vegan diet, cycling to work and recycling combined. It's a very fudgy kind of calculation that I wouldn't put too much kind of credence to, because ultimately the impact of switching to a more plant-based diet has all kinds of other effects which are not accounted for there. Recycling as well has all kinds of other effects which are not accounted for there. But the point is, it's just like a shockingly large number to make it clear that actually shifting your pension can make a huge amount of difference. Okay. Francesca was asking, why is it problematic to look at our individual consumption according to carbon emissions? So I don't think it's necessarily a bad thing to think about the carbon emissions of what we're doing with our lives. But I think it's a bad thing for that to be our key motivator, because it can be extremely distorting. One of the biggest problems with humanity is that we kind of get really obsessed with like one-dimensional metrics. And what I mean by that is, like in TV, for example, they're obsessed with how many viewers it got. There's rarely a question of what kinds of viewers, did we attract a diverse audience, what was the quality of their viewing like? It's always just number of viewers. And similar thing exists in the economy where people just optimize for money. You know, companies optimize entirely for profits, and they're not optimizing for other things. And that is one of the things that can be very problematic in the world. And I think that if we try to solve the climate crisis by optimizing entirely along the kind of metric of carbon, things could get very dodgy very quickly. And so a good example of this is, so a lot of governments got really involved in something called biomass or biofuel, where they basically like plant a load of elephant grass, and then the elephant grass grows, and as it does so, it absorbs carbon dioxide from the atmosphere, and then you cut it all down, you burn it all, and you use that to create electricity. And then that releases carbon dioxide. But then you plant more elephant grass, and then you capture that carbon dioxide again. So it seems like it makes sense. It's something that's been thought about along this kind of like carbon metric. And so people are like, yeah, sign off on that. That seems like a thing that will work. But actually what it's not doing, which is really problematic, is taking into account the broader, much more important question, which we'll talk about more as sessions evolve, which is about what's the impact on the natural system as a whole, what's the impact on nature overall. Because ultimately, as we'll talk about later, if you plant a whole field of elephant grass, then you basically start degrading the soil. And as the soil degrades, loads of carbon dioxide pours into the atmosphere. And that's not being measured because people are only measuring the elephant grass on the surface. So I guess you could get to the same answer by just measuring in terms of carbon, but it's hard to ask the right questions if you're only measuring in terms of carbon. It's much better if we think about how our actions have a positive or negative impact on nature. It's a much more important question than emissions. It also might help when choosing to buy things in a supermarket, if we're thinking about like, should we buy something that's wrapped in plastic or not? But anyway, we'll talk more about plastic in session 3 rather than going too into depth about that now. Okay, so, oh, cool. Thank you. Sorry, I'm only calling you P Grafman, but thank you, P. I'm loading this page. I hope it's not going to start playing automatically. Okay, good. Right. I think maybe we're getting to a point where we've probably wrapped up most of the questions. So what I'll say is do come along on Friday if you'd like to come. It's 12:30 UK time and 12:30 PM. And so you can ask any questions that you like there. It's keep calm and ask on Fridays is what we are calling it, and you can find that on any of our socials or most easily by the Facebook community. So please do also share AimHi Earth with your friends, colleagues, family, and world leaders. Here are all the links again in case those are useful for you, and do look out for the email with your after session pack as well. And we will see you next week. Thank you so much for coming, everyone. Farewell.